My name is Andrew Hall. I'm one of the program manager leads for .NET and Azure tools in Visual Studio.
And I'm Paul Yuknovich. I'm one of the lead program managers on Visual Studio and Azure. People also don't know this. I'm Andrew's twin brother.
It's true.
Yep.
So, big crowd, appreciate that. We're going to try to go really quick because Azure is obviously a very big topic, and trying to get through anything Azure related in 20 minutes is going to be a challenge, but we decided to accept it. So we're going to talk about 5 Azure services every developer needs to know about. And our goal today with the talk is to help you understand what you would need to get started with Azure. A lot of the things we're going to talk about, we would recommend as your starting place. Some of them would meet your needs forever. Others of them, as an application grows and gets bigger, you might graduate out of. So we're going to talk about 2 different pieces of terminology when we talk about Azure services. So we have to define our terminology to start. The first is the difference between hosting and a service. So we've defined hosting as any place in Azure that you provide your code, and Azure is going to execute the code that you've written. So an example of this would be if you write an ASP.NET web application and you upload that to a hosting site, right? Azure, or whoever your host is providing the service that is storing that and providing the CPU power, but whatever logic is executing is the logic that you've provided in the context of your application. A service is where you provide data or information to it, and Azure's implementation takes action on what was provided. So an example of this would be blob, so binary large object storage. So if you have an application that stores photos, for example, the user uploads photos, you send the stream of bytes to storage. Azure's implementation understands what to do with that. It understands where it goes. All you know is you give it some data, a stream of bytes, and then when you ask for that data back, you get a stream of bytes back from Azure. You haven't written any code. Azure takes care of that.
Can I almost think of it as IaaS and PaaS is the hosting, and then SaaS are services?
Yeah, so he used 2 terminologies. So IaaS, infrastructure as a service, or SaaS, software as a service. And then PaaS, P-A-S-S, platform as a service. So.
All right.
Great. With that, let's move on to our first service. This is a hosting service, and we think if you're looking to get started with Azure, the place that you want to start as your hosting option is Azure App Service. It supports web applications, mobile applications, API apps, and logic applications where it lets you stitch together events and, in a very graphical way, build an application that has a flow to it. This is a fully managed service in Azure, meaning that Azure takes care of patching and upgrading all of the underlying dependencies. So as Windows patches come out or Linux patches come out, depending on which one you're using, those upgrades will get applied. You don't have to do anything. You don't have to change anything about your application. If the version of .NET you're running on ships a servicing update, Azure will apply that on your behalf.
Yep. If the servers go down, Microsoft's basically on the hook to deal with it.
Correct. People do not sleep until they get turned back on.
Yep.
It is first-class Visual Studio integration. We will take a very brief look at that here in a minute. It has really awesome diagnostics and monitoring integration. You click a couple buttons, and you're getting really rich telemetry and troubleshooting information.
We're going to show that, right?
And we're going to show that. That's going to be the last service we're going to look at.
Yep.
And then there's really another really awesome feature is something called deployment slots. And I'll briefly show you how to get started with those. But what those do is those let you either do A/B testing or stage deployments, warm them up, run tests against them in the same environment. Then you just click one button, and now all of a sudden that's what's running in production. The other one gets swapped out. You can take it down. You can push updates to that.
So if you've heard like blue-green or VIP swap, it's kind of that idea, right?
Exactly.
Yeah.
So the second service that we want to talk about is Azure Function Apps. These are relatively new. I think we first announced tooling in Visual Studio, for example, for them at last year's build. And this is event-driven execution off of lots of different events in Azure, depending, there's 20, 30 different events you can queue off of, but some of the more common ones are HTTP, queues, or blob storage, database events, timer events, and they're awesome for running workers, or depending on what you want to do with your data, they're really, really cheap because you only pay for resources used during execution. So we have some people called cloud developer advocates who write tools. Somebody wrote a URL redirector, so every time they write a blog post or tweet, they send it to their function app. he, I think, said he was paying like 10 cents a month for execution, as opposed to some of the other places where you would host that you're looking at starting at about $40 a month.
I think it's good for things that start and end, like jobs, or probably not something that's incredibly chatty. That's when you'd want to look at an API app, right?
Correct, yeah. So you're paying per execution, so if it's low volume and if it's event-driven and it's very finite. So, and we will look at a brief sample of this here in 1 minute. And so it's serverless. Serverless is the terminology that means you don't think about, so anywhere else in Azure, even App Service that we looked at a minute ago, we ask you, how many resources do you want for your application? How much should Azure reserve? How many cores do you want? How much RAM do you want? And you're going to pay a fee for how many resources you've reserved for that. Yep. In serverless computing, you simply say, here's my code, and the server decides how busy they are, how many instances to spin up, how many instances to spin down.
It's almost the way managed services and PaaS should have always been, right?
It is how managed services and platform as a service should have always been. That is correct.
Yeah.
And so with that, let's jump into a brief demo of Azure Functions. So Paul and I
got it.
have written a very simple web application that is a photo gallery application. So what it lets a user do is it lets a user upload an image, and then it writes a little watermark into it. You might be able to see it right down here. And so how we've chosen to build that application is when I click the upload, it gives me an upload. It's going to write that into a blob storage, binary large object storage account. And then I have an Azure function that is going to pick that up, actually do the watermarking, write that into a new container. And so the event, my web application doesn't talk to my Azure function at all. I already have my Azure function here up debugging. There's a first-class application type in Visual Studio. And instead of using my portal to show that I'm not doing any tricks, I'm going to upload an image here using Storage Explorer.
Has anybody written a service or an app that uses MSMQ, something like that? This is kind of like the modern cloud version of that, right?
So this is a developer tool.
Yep.
Storage Explorer, great for working with Azure Storage. And so when I click Upload Files, it's going to let me browse for a file. So is it in your Pictures folder, Paul? Perfect. So let's go ahead and do this. I'm going to click Open. And then I would expect within a few seconds that my event is going to fire and my Azure function breakpoint is going to hit. So I'm doing local event-driven development, right? There was no tricks. My web application didn't talk to it all. I wrote directly into the storage queue, and now that event has been queued off of. Now there's a second function in here just to show how I can chain these together. So if I look at my function app, so delete original image, and what this one's going to do is it's going to look for the, so when my current function finishes executing, if I can find where I was, it's going to write this into my second container, which is my watermarked blob storage container. So my second function in Visual Studio, again, this is all event-driven, is going to look for changes to that container, and then it's going to go back and clean up my original image. So let me go ahead and hit Continue. This one will finish executing.
It's all kind of asynchronous, right? So it could happen anytime.
It could happen anytime, that's correct. And then boom, my second function has executed.
Sweet.
So I mentioned that we have first-class support in Visual Studio for working with Azure App Service and Azure Functions. To move my core image gallery, the web gallery portion of this that's already up in Azure for the sake of time, here's the public URL that we have up in Azure. I would simply right-click on this. I would say Publish. And Visual Studio is going to give me an experience that's going to let me publish this up into Azure. And it would take me, on a normal network, not at a conference, probably about a minute to a minute and 30 seconds to have that web gallery application from my local machine up and running into Azure App Service. And once I'm there, I mentioned some really great functionality that we have available in Azure App Service. So this is the portal, the blade. And so if I go down here to Scale Up, this is Scale Out is what I want, right?
Yeah, Scale Out is like more instances, more nodes. Scale Up is better hardware.
So
right?
if I decided that the application might get busy, I can drag a slider. I can increase the number of instances of my virtual machines that I want. The limit is 10, so if you need to go beyond that, I mentioned you might graduate past app service.
I actually like putting a request to IT people, so can I still do that, or do I have to do it this way?
You sure? You can put in a request to an IT person if you want them to go slide the slider too.
Sure. Okay.
Yeah. Or there's the other option that you can just click one button and we can enable auto scaling.
Cool.
And with that, I'm going to turn it over to my twin brother.
Nice. He's just a little taller than I am. Other than that, it's about the same. All right. So.
You're on a.
Yeah. All right. So just to capstone what happened there, Andrew showed a front end using app service, a back end worker using functions, and really the glue that you had holding it all together was storage. Storage, to me, it's like air. You have to write to stuff. We've always written in the file system. So I think in that case, use blob storage. That's like HTTPS addressable objects or files. There's other notable mentions here. Really cool thing about storage, I don't know if we hit on it, it automatically geo-replicates, which is a really hard job to do yourself. Let Azure do that for you,
well,
right?
Automatic, there's a checkbox, but yeah.
Yep.
Yeah, one of the cool things about geo-replication that's worth mentioning is if you turn it on, it effectively guarantees that your storage will never be unavailable. In the rare event that an particular Azure region is unavailable for a few minutes, geo-replication will automatically pull it from a different region. So if you geo-replicate storage to at least 2 different regions, the odds that that anything in storage would ever be unavailable is almost 0.
Right. And we almost had to use it last night. There's a lot of built-in safety features, like you can archive basically your data so that there's no risk of deleting it, soft delete, snapshots, that kind of stuff. All right, so what I want to pop over to now is let's think about databases. What we would recommend for the 4th service is Cosmos DB. Cosmos DB is really a modern object store database, and it's really great for what I think of as domain objects, or you could think of business objects, domain objects, whatever is the focus of your application. What's really cool is you just continue working with objects, whether they're ordinary POCO objects, Java objects, whatever, and you write them straight into the database and you query them right out. So I don't know, who's spent a lot of time doing like object relational mapping, entity framework, things like that. I mean, that's a good technology, but it's really a lot of work and it's kind of thankless. So you can just work straight with your objects that look like your app, that look like your business, and write them off. So I really love that. There's almost a number of different languages that Cosmos DB speaks. So if you're familiar with SQL or MongoDB or Graph API with Gremlin, you've got all these different choices. Even Azure Storage Table, we re-platformed that framework on top of Cosmos so you can get the better globally distributed massive scale kind of characteristics of Cosmos DB still using the familiar easy API of tables. So I'm going to show that one. So why don't we pop over? All right, so let's look at code. So I mentioned that this is really handy for our domain objects. And Andrew, remind me, where do we put our
services, images? AZ storage service.
Right. And how about the actual image class?
It's down.
OK. Andrew's an overachiever, so it looks like he refactored it last night, so I'd be totally confused. OK, awesome. So I mentioned that really you just stick with the POCO objects or the objects that look like your domain. So here, not only do I have an image, but I have a little bit of metadata. I want to know the path. I want to know when did this thing get uploaded and who uploaded it. And that is additional information that helps us have telemetry, have a little bit of an audit trace, right? And that's just a very simplistic example of the kind of objects that we might have in our apps. And then if we float over to the service class that we wrote, which is right here, all we're going to do is we're going to connect to the database just using a connection string. And we're using user secrets, which is a topic for another time. And in this instance right here, let's make it a little bit bigger. After we go ahead and basically query for the data that we care about, the list of images, what we're going to do is write to the Cosmos DB database. This is the initialization. So where do I want to go? This got refactored again.
Up. No, there you go right there.
OK, yeah, really simple. So this is the focal line that I want to focus on. To do CRUD like this, you simply just call a one-liner API, like create document. An object is a document. Just create it, point to the database, give it a collection ID. The image is the actual object, and off you go. So really persisting your objects to a database has never been easier. Also, querying is really simple because to do this in the relational world, we have to understand things like indexing, indexing columns, so that you can really optimize, your queries for the way that your app wants to work to do it. In Cosmos, automatically every property of your document is automatically indexed, and it makes it really incredibly easy to search on any dimension and pull these objects back out. So that's what I want to focus on with Cosmos. Another little, I'll call it a pro tip, but if you have this Azure Storage Explorer, which is a free tool, your Cosmos DBs are going to show up in here as well. So here's the actual Cosmos DB we're writing to.
All right, Paul. So instead of just showing me what we've written, why don't we actually upload an image? Let's
okay.
show that this works.
You want to keep me honest?
I do want to keep you honest.
Okay, this is the non-marketing demo then, right? So sounds good. Andrew's a tough character. So
yeah.
Normally what I would do is I would log in, but in this case he made it so incredibly easy. I'm just going to upload this. This picture actually looks pretty cool. All right. Did that work? I actually don't see any images there. Let me try that again. Let's try this one.
Oh.
I'm getting some errors.
So, correct me if I'm wrong, Paul, this is up in the cloud, right?
Yeah.
So how am I going to debug that?
Yeah, how do I debug that? So perfect tee up. In the cloud, a great thing to do is to use logging and metrics. Like I can't strongly recommend that enough. Logs and metrics are always there. They give you a ton of information. It's great to put some time into it. But the thing is, to get that level of log and metrics, we find ourselves writing a lot of trace code. And it's really hard to get that tracing right. You can end up over-tracing or under-tracing. So what we're going to use is our actual fifth service, and we'll pop over. Our fifth service is Application Insights. And Application Insights gives you a built-in application performance monitoring service, or APM, and it specializes in logs, metrics, and even additional things that are more app-centric, right? So like your requests, your dependencies, and even correlation ID. App Insights, just by including the SDK, it's automatically intercepting all of these things, and it's building this additional information. So when you go back to diagnose your app, all that stuff's just sort of waiting there. Other things I want to mention is, you mentioned debugging. You actually can do debugging in prod with a snapshot debugger that we have that will take in-memory snapshots, save them off for you, and you go debug the snapshot instead of debugging prod, because that's a bit of an occupational hazard to do that.
It is.
As it turns out. So let's go look and see what App Insights did. So honest to goodness, all we did is use standard iLogger, or you could use Serilog, or you could use Log4Net, or any of your favorite things. We enabled App Insights, and now look at the kind of things that we're getting. So we could go to this application map, and without writing any code or spending any time in Visio, it actually auto-detects all the tiers and components of our application. So we could see that image gallery web front end is getting a lot of the traffic. And there's actually some errors going to our Azure blob. I should go check that out. We can also see that the function that Andrew worked on is hanging out there. And that one's actually a little bit more healthy. Now, so that gives us kind of an overview of what's running. Now what I'd want to do is look at things like failures. And I can see that App Insights will use this telemetry to kind of build up intelligence and actually tell me what my top 3 exceptions, dependency failures, or response codes are. And you guys could you can use this query language we have called analytics, which will go ahead and give you more control. Now, I've been throttled all day because it looks like Azure, it looks like I'm DOS attacking it with our demos. Here we go. So you can see actually null reference exceptions, blob, and even 500s, and the correlation between it is something that we can easily get from here. This is a topic that's much longer, and I actually have a 75-minute talk just to go through this at 3 o'clock. So if you're interested in this, go ahead and check it out.
Awesome. Thanks, Paul.
Yep.
So hopefully this was a good whistle wetter. Mentioned, go check out the diagnostics talk that Paul has. Slides are available if you want to download them. We have a whole thing of honorable mentions for services we couldn't talk about. And thank you very much for attending.
Thank you.